Hello students, let me give an video presentation on the topic of waveguides. In this presentation, what are the topics we'll be discussing is I'll be giving you what does the term waveguide refers and what is the difference between guided waves and unguided waves. Similarly, we will be discussing on the construction wise of a waveguide and what are the features and applications of waveguides. Okay, what does the term waveguide refers? You have two terms, that is waves as well as guides. As we all know that what is wave? It is defined as a mean of transporting the energy from the source to destination. So it is a particle which is moving in the space with respect to time. It may be in the form of a wave with respect to time. Okay, now let us see what is guided waves as well as unguided waves. If you take unguided waves, the waves which propagate in unbounded medium and the electromagnetic energy associated with radiation over a large area. Unguided waves means you don't have a specific boundary. You can take as an example as our towers, where you can see that the radiations will be there. It will be in the form of electromagnetic waves, and you can also take an example as our satellite. In case of Earth station, the waves will be uh, radiated from the Earth station, and the same electromagnetic waves will be received from the satellite, and again it will be sent back to the Earth station. So these type of electromagnetic waves which doesn't have any specific boundaries, then we can call that particular waves as unguided waves. Okay, then what is guided waves? A guided wave means an electromagnetic wave which propagates in a guided structure. That means you'll be having some specific or confined boundaries. Any examples for guided waves? If you take guided waves, then you'll be having a coaxial cable where you'll be having different boundaries inside a coaxial cable. In one point where the signals will be transmitted, and in the other point you'll be receiving it. Some of the examples for guided waves will be in the form of waveguides, the best example, where you'll be having a confined region of different planes. You'll be having horizontal and vertical planes, and in between the horizontal and vertical planes the electromagnetic waves will be radiated, and based on the reflections it will be moving from source to destination. Okay, now let us see the construction wise of a waveguide. Since we have some idea about parallel wire transmission line, as you know that for a parallel wire transmission line, two conductors with same specifications will be separated by an equal distances. And you might be also studied about stub matching, where we'll be using a quarter wave transformer. It will be connected as a stub for impedance matching. In the first diagram you can see here that a parallel wire line which is connected along with a stub. So if this particular setup has been repeated again and again, then you will be having some multiple sections. Okay, so once if the multiple sections are there, that means you are confining for the transmission line for a specific area. So repeat the process in case of both sides. You can also include the same steps either in the top portion as well as in the bottom portion. So once if you increase the number of sites along with the quarter wave sections, then finally you'll be having a bounded structure, something like this, where you'll be having a complete confined medium. That medium we'll be calling it as a waveguide. Okay, what does the waveguide means? Waveguides are employed for transmission of energy at a very high frequencies. So normally the frequency ranges will be in the range of gigahertz, where the attenuation caused by the waveguides is very small when compared to our open wire transmission line. Okay, now let us see some of the features of a waveguides. If you see the features of a waveguide when compared with the other transmission lines, the power handling capacity. The power handling capacity is around 3 to 5 times lesser when compared to It may be either a coaxial line or a parallel wire line. The power loss is also reduced. That means in the form of attenuation. If you take it for a coaxial cable, it will be in the range of 13.7 dB. But if you take it in the range of waveguide, it will be 1.9 dB alone. It is reduced 10 times. Okay, the operating frequency. The operating frequency of a waveguide will be very higher when compared to other types. So in case of coaxial lines, the operating frequency will be in the range of 18 gigahertz, but in case of a waveguide, it will be in the range of 325 gigahertz as a maximum. The construction wise of a waveguide is very simple and it is very rigid. Okay, now let us see some of the applications of a waveguide. The waveguides are used in microwave transmissions, and circular type of waveguides are also used as attenuators and phase shifters. Now let us see what is the applications of a waveguide. The waveguides are used in something like a telephone uh, transmission, where the voice signals need to transmit from one point of the earth to another point of earth. Where in the telephone exchanges they'll be using these rectangular type of waveguides, and it is also used in the antennas in case of satellite communication. If you take a satellite communication where you will be using transmitting antenna as well as receiving antenna, in both the antennas the waveguides will be employed for transmitting the signals and receiving the signals. Similarly, in case of our mobile communication also, we'll be using different type of small waveguides. So waveguides plays a vital role in the transmission line. Okay,